So now we will move on to exercise 1b. This is still quadratics, but it's more about completing the square. And this is still pure maths. So basically the first lot of questions wants us to express our quadratic in the form sum x plus a squared plus b. And so the first is x squared minus 6x. This is easy, as you know, because there's no constant. So we halve the coefficient of x, add a squared, minus the square of that. Easy. X squared plus 8x. Same thing. I should probably do equal signs. You halve it. And this is starting to look rather repetitive, but now we're starting to get sum c, which will add to some extent an extra step. So remember, we just look at the first part, subtract the square of that, then we add that, make sure we add that constant back in. Remember, we're halving this, putting it in brackets and squaring it, subtracting the square of this, then adding back that constant. And when I say add, I mean if you add a minus, you're subtracting it. But if you're adding a positive, you're adding it. And I think you get what I mean. If you have to, don't be afraid to use a calculator so you don't make a mistake. And so that's basically the first essential part of completing the square, this process. So if you're familiar with all of this and how to do all this, then you'll be well set for lots of different questions in AS Maths. And now we add in the case where the coefficient of x squared is not 1. And so in this case, we're looking for the form of this. And we'll just get into it. And what we do is we first divide the first two parts by 2. And we leave that constant alone. Now we do the square brackets thing, and we do our completing the square by halving that coefficient of x, adding a squared, then subtracting the square of that. We do a partial expansion. Be careful of your signs. And we get that. And then the next one, example, is 3x squared minus 12x minus 1. And for C, we have 2x squared plus 5x minus 1, that's like that. Now, here's a helpful thing. If you're worrying about how to halve things, you can always just double the denominator. For D, we then have 2x squared plus 7x plus 5. This is equal to 2x squared plus 7 over 2x and plus 5 brackets. We complete the square. I think you probably are starting to get the idea. And this is how you complete the square. Now, here's another case, another different form, another different version of the completed square form you could do. And this occurs when the sign of the lead coefficient is negative, because we kind of like our first thing to be positive rather than negative, which is why we do this. And for the time being, we're going back to only having a lead coefficient of -1. So we'll get into it. So we start with the example of 4x minus x squared. Honestly, what I would do is I would honestly convert it into this form first and then change it back into this form later. Then I would divide it by -1. Then I would complete the square. Then I would expand, and then I would rearrange. Now this way of doing it just reduces the chance of error and makes the working much clearer, and you don't get confused. But you may have a different way of doing that. Right, I'll go into a new page here. (8x minus x squared). This is equal to -x squared plus 8x. And this will be like this if you factor out the -1. Then you complete the square. You halve that 8, then you square that 4. Expand, rearrange. Now we have this example. And this is equal if we rearrange it and factor it out. Complete the square. Square that and take it away. Expand. This gives us -x plus 3 over 2 squared plus 25 over 4. And so we'll just boot that to the front. D, we have 9 plus 5x minus x squared. This is equal to -x squared plus 5x plus 9 minus x squared minus 5x plus 9 x minus 5 over 2 squared minus 25 over 4 plus 9. And so this will give us, this just gives us 61 over 4, and I will speed things up and just take it straight to the front. And then if we just keep on going to the next set of questions, it's giving us another kind of form it wants. And this is essentially the same as this, except the coefficient of x squared won't be -1, it'll be -2, -3, -4 sort of stuff. So in the first one we've got 7 minus 8x minus 2x squared. And again, I suggest you rearrange it. Divide it by that coefficient of x squared. Leave the constant out of there. Then you complete the square. And so this will give you, and I'm just going to bring that straight to the front, that 15. And it's the same thing again. We rearrange it to get it in that traditional order. Then you divide. Then you complete the square. (18 plus 3), and that's 21 minus 2 bracket x plus 3 squared. (13 plus 4x minus 2x squared). This is equal to minus 2x squared plus 4x plus 13. Divide by that lead coefficient. Complete the square. Bring this to the front. Again, I sound like a broken record. Rearrange it to make it the x squared, then the x, then the constant. Divide by the lead coefficient. You don't divide the constant by the lead coefficient though, you leave that out. Then you do a square bracket. You complete the square by halving the coefficient of x, and we're doing this by doubling the denominator. We add a squared, then we must minus the square of that thing, of the halved coefficient of x. Then we expand partially. And then we'll add this part at the end and then move it to the front. So that's 49 over 12 minus 3, x minus 5 over 6. And then we'll square that. Now it wants us to do a form of, within the bracket, ax plus b plus c. So that means we actually don't want to extract that a fully when we complete the square, and we'll see this in an example. And this means that we've got perfect squares involved. So if we have a look at 9x squared minus 6x minus 3, notice that 9x squared is just 3x squared. So this is just going to be I would do a 3x and then I do minus. What I'll do is I would divide it, to figure this out, I would divide this bit by 3x and I would figure out what we get. So we have 9x squared divided by 3x will just be 3x, and then if we do minus 6x divided by 3x, we'll just get 2. And this is 3x multiplied by 3x minus 2. And this will be the same as, we can do a bit of an attempt to complete the square in some sort of doing 3x minus 1, halving that, squaring it, and then just accounting for getting rid of that 1 later and minusing that 3. And that gives us 3x minus 1 squared minus 4. And because, remember, when we expand this, we'd do minus 1 times 3x. That would give us negative 3x. But remember, we'd do that twice because a plus b squared is equal to a squared plus 2ab plus b squared. And that's how we'd get to negative 6. So we're still doing that thing of halving it. And then, of course, squaring that to get rid of it. And then the next example would be 4x squared plus 20x plus 30. So when it's told that you're doing this sort of thing, you know that this has to be a perfect square. So you take the square, you imagine in your mind, you take the square root of 4x squared, and that gives you 2x. So you think this is equal to 2x plus 10 plus 30. So this means you're aiming for 2x plus 5 squared. And then you'd have to subtract the 25 and add the 30. So that gives you 2x plus 5 squared plus 5. Because it wants this specific form where you keep some coefficient of x within that bracket. And now in the next one it wants 25x squared plus 40x minus 4. And this time we have a 5x here. So we factor out 5x. Then we halve that 8. Subtract that square of 4. And then combine those constant terms to get that, and that's your answer. Now for D, we're going back to a 9x squared sort of thing. So this will be equal to 3x multiplied by 3x minus, is that 14? Still got 61 here. Leave that constant alone. And then we get that. Easy. Now we're actually getting into solving equations with completing the square. And the first one it wants you to do is x squared plus 8x minus 9 equals 0. So just start completing the square. put this on the other side, 25. Bang. So x plus 4 is either going to be 5, or x plus 4 is equal to be minus 5. X is either 1 or x is either minus 9. Next one, x squared plus 4x minus 12 equals 0. X plus 2 squared minus 4 minus 12 is 0. So this means x plus 2 squared is equal to 16. X plus 2 equals 4. X plus 2 equals minus 4. X equals 2 or x equals minus 6. In C, we have x squared minus 2x minus 35 is equal to 0. We'll do a completing the square. This means x minus 1 squared is equal to 36. X minus 1 will then equal 6, or x minus 1 equals minus 6. X equals 7. X equals minus 5. And I do this because we take the square root. If you got to remove a square, you do a square root. I would think that's quite self-explanatory. Now the next problem is x squared minus 9x plus 14 equals 0. Complete the square. We halve that 9. Then we subtract the square of 9 halves. Add that constant term back. And then we end up with this. So this means x minus 9 over 2 squared is equal to 25 over 4. X minus 9 over 2 will be the root of 25 over 4, plus or minus, remember. So that means x minus 9 over 2 is either equal to 5 over 2, or x minus 9 over 2 is equal to negative 5 over 2, in which case x will be 14 over 2, which is 7. Or x will be 4 over 2, which is 2. E. X squared plus 3x minus 18 equals 0. X plus 3 over 2 squared minus 9 over 4 minus 18 equals 0. X plus 3 over 2 squared this is minus 81 over 4, which is equal to 0. So x plus 3 over 2 squared equal to 81 over 4. X plus 3 over 2 is equal to 9 over 2, or x plus 3 over 2 is equal to minus 9 over 2. X equals 6 over 2, which is equal to 3, or x is equal to minus 12 over 2, which is minus 6. If we got x squared plus 9x minus 10 equals 0. X plus 9 over 2 squared minus 81 over 4 minus 10 equals 0. So this gives us x plus 9 over 2 squared. On the other side, if you add that up, if you subtract away that 10, then you add it to the other side, you'll get 121 over 4. So x plus 9 over 2, that's either going to be 11 over 2, or it's equal minus 11 over 2. And then you subtract that, you'll get 11 minus 9, that's 2. So 2 over 2 is 1. Subtract that again, negative 20 over 2, which is minus 10. And that was kind of easy because no coefficient of x squared greater than 1 involved. But now these examples will have coefficients of x squared greater than 1. X squared plus 4x minus 7 is equal to 0. Well, some of them will. The first three will not. Then the second the second three will. And also these ones won't be rational numbers. I think that is the key point. So this is because it tells us to leave them in third form. So that's minus 11, so we have 11 on this side. Okay, here we can see they won't be perfect squares. And that's plus or minus. That means x is either equal to minus 2 plus root 11, or x is equal to minus 2 minus root 11. B, we've got x squared minus 10x plus 2 equals 0. X minus 5 squared minus 25 plus 2 equals 0. X minus 5 squared equals positive 23. X minus 5 is either is plus or minus root 23. So that means x is equal to 5 plus root 23, or x is equal to 5 minus root 23. C. X squared plus 8x minus 1 equals 0. X plus 4 squared minus 16 minus 1 equals 0. So this means x plus 4 squared equals 17. X plus 4 equals plus or minus root 17. X equals minus 4 plus root 17, or x equals minus 4 minus root 17. D. 2x squared minus 4x minus 5 equals 0. And we must complete the square by dividing the first bit by 2. Leave the constant alone. And then do that partial expansion. And then move that over to the other side. Now, the next step is to divide by that 2. That's just the extra step. Now, x minus 1 will equal plus or minus the root of 7 over 2. Now, perhaps you want to rationalise that denominator by making it plus or minus root of 14, because root 7 times root 2 is root 14, and then root 2 times root 2 is 2, because we've just done this by doing... Those will become... Because that's the same as that. We got just a normal 2 here, and on top we have that. That's how you rationalise the denominator, because you don't like surds in the denominator. And so that means x is either 1 plus root 14 over 2, or x equals minus 1, no, x equals 1 minus root 14 over 2. E. 2x squared plus 6x plus 3 equals 0. 2x squared plus 3x plus 3 equals 0. To complete the square. That. Move the constant terms to the other side. Divide take the square root, plus or minus, don't forget that. This means we'll get equal minus 3 plus root 3, all divided by 2, or x will equal minus 3 minus root 3 over 2, because root 4 is equal to 2. Two x squared minus 8x minus 3 equals 0. To x squared minus 4x minus 3 equals 0. Complete the square. Expand. Move those constant terms to the other side. X minus 2 squared equals 11 over 2. X minus 2 will therefore equal the plus or minus root of 11 over 2. X is equal to 2 plus root 11 over 2. X equals 2 minus root 11 over 2. Now remember, we can rationalise this denominator. So that would make this root 22 over 4, because we're multiplying by root 2 over root 2. And this would be 2 minus root 22 over 4. Now 8, we have to solve this equation. And like we did previously, we will multiply by those denominators to get a common denominator. And then this and because all those denominators are the same, we can remove them from the equation. And then I'll expand this as we go along. Right, and now we'll move everything to one side. And now we must complete the square. Sorry, I think I've made an error here. This is just minus 1. Minus 1. So this will be x minus 3 squared is equal to positive 10. X minus 3 is equal to root 10 plus or minus. So x is equal to 3 plus root 10, or x is equal to 3 minus root 10. Right, next we've got another geometry thing. This is x, this is 10, this is 2x plus 5. Right, and we're going to use Pythagoras. We just need to solve for x. So we know that x squared plus 2x plus 5 all squared will equal 10 squared. Expand this, we get 4x squared plus 20x plus 25, and this is equal to 100. Now we got 5x squared plus 20x, and then we'll do minus 75, and that's equal to 0. Divide by 5. And now we must complete the square. And that gives us 19 on the right hand side. Plus or minus root of 19. That means x will either equal minus 2 root of 19 So minus 2 plus root 19, or minus root 19. But remember, we have to reject this because we're dealing with side lengths and it's going to be positive. So that's our only answer here. Now, okay, 10. It wants us to find the real solutions of the equation 3x squared plus 5x minus 7 to the power of 4 is equal to 1. Now, here's a few things. Real solutions, that means we don't want complex numbers, so taking roots of negative numbers is still not something that we do in AS. And remember how this could be telling you that could be saying this. So let's try that. But remember that because we've got even powers here, this can also be equal to -1 all to the power of 4. So we need to do the two cases. Equals 1, or 3x squared plus 5x minus 7 equals -1. Now, I think because this exercise is about completing the square, we'll just complete the square. Over 36. And notice how I just doubled the denominator to halve it. That's, I mean, I don't need to spell it out for you, but it's worth saying that. Some people don't jump to that. And we'll just move that stuff to the other side. And then we'll divide this by 3. Right, so this one here actually isn't going to be irrational. So x plus 5 over 6 will equal 111 over 6, or x plus 5 over 6 will equal -11 over 6. This one here will just be 1. This one here will just be -16 over 6 will be 8 over 3, -8 over 3, yeah. And on this side, I suspect these will not, these will have to give third answers for. We kind of have to do very similar stuff here. But honestly, because they are identical in the first parts, I'll copy this over and just change this up. And that will just, we just need to get rid of 2 lots of 36 over here, I think. That's 97 over 12. And so this will give us, and then we must divide. And then this gives us root of 97 over 6 plus or minus. So x, that's either going to be minus 5 plus root 97 over 6, or minus 5 minus root 97 over 6. Those are our 4 answers. Now, question 11, the last question in this exercise, we've got the path of a projectile is given by the equation of y of root 3x minus 49x squared over 9,000. And x and y are measured in meters. So what we're saying is a flight of a ball perhaps resembles a parabola. And so at any point on this path of trajectory will be what x and y are related by this equation. So it wants us to find the range of this projectile and then the maximum height reached. So a range. And we're trying to go from this part to this part. So the range is just going to be the distance between the two roots. The 2 times it'll be equal to 0. So if root 3x minus 49x squared over 9,000 is equal to 0. And if we move this, try to separate this stuff out. We get 49x squared over 9,000 on one side, being equal to root 3x on the other. And then if we, well, honestly, if we just actually move it to one side, and then we can factor out something. So this means for one of them, x will be equal to 0. And then for the other one, we'll have this. Equals root 3. So then we'll get 9,000 root 3 over 49 x equals. And because the range will be this bit minus that bit, this will be the answer. That's in meters. And if you wanted it in decimals, just to actually give you a proper idea of this actual range, then that would be 318 meters. Now for B, wants the maximum height. And this is another reason why we do completing the square. Because when we complete the square, and you get the form of ax minus b squared plus c, the maximum point is actually at b, c. Now, I will show you a way to do it by completing the square, and then I can show you a bit of a shortcut for this question. So what I would do is I'd do this, and then this would have to be, when you divide it, remember you're multiplying by the reciprocal, so it's actually over and then you can complete the square. Squared minus and then you just have to expand this. and then honestly get out your calculator and compute this on there. And that gives us this. And so yes, and remember that I've made a slight error here. We actually should be having the negative signs there, which would make this positive. Yep. And so this will be our maximum height, which is about 138 meters to 3SF. Now the shortcut would be to know that, okay, the maximum will be in between the two roots, and if you do that, you get 4,500 over root 3 over 49. And then you would just substitute that in to this equation, and then you get that answer. So just to cap off this video, it's all about completing the square. Here's some simple examples. You may be asked to write it in a certain form, and you just go through the motions of completing the square. You halve that b coefficient, that x coefficient, square it, remove it, ignore you leave the constant alone and add it back in later. You just follow the same process with, if the lead coefficient is not 1, you just have to do that extra step of division and then multiplication later. Sometimes you might have negative, so just honestly get it into that same order you want it, x squared, x constant, then put it in the form once you've completed the square by rearranging. Same thing with this stuff, it's just the lead coefficient isn't -1. This bit, same thing, but remember you divide by the square root of that first term first. Using this to solve equations, sometimes you might have third form. Remember, it's good to rationalise the denominator though. And then more stuff like that, and then literally just more completing the square. And these are just problems that you just need to get past all the words and just find the numbers. But that's it for this exercise. I'll move on to 1C next time.